This is really a bit of a follow-on from my colleague's talk yesterday by Rebecca Filand, where she was canvassing for universities and communities to be involved with NRM assets, etc., for training and research. I'd also point out as well that it's a linkage. There was a question from the floor yesterday about people working with local councils, and that's come out pretty strongly in the last couple of talks. And I'd like to acknowledge that Glyn Ricketts is the Water Resource Manager at Marion Council, and he's been a real champion of the Oaklands Park wetlands and the engagement with the university, along with the local government associations. This is a real example of what can be achieved with council engagement and university engagement. So the Oaklands Park wetland, I managed the input studies program for the Adelaide Coastal Water Study, and stormwater was seen as an issue because of suspended solids. And the wetlands were seen as one intervention that would manage suspended solids. So what we've got here is the Sturt drain, goes through a deep ponding system for settlement, then through a reed bed. And this system, the wetlands, is there to stabilise the stormwater. By that we mean deal with nitrogen, phosphorus, carbon, suspended solids. And when the water is of sufficient quality, it's injected... I've done the same thing. It's injected into the T2 aquifer, and I think you've got to remember that word there, which I'll talk about later. It's down as the limestone T2 aquifer, and we'll pick that up later. It's injected in the winter into the aquifer. It's reclaimed in the summer. It's stored in a buffer tank, and then it goes through an irrigation system. It's used for irrigation of green space. And as part of the integration with the university, there is now discussion with Marion Council that not only is this an intervention to improve the suspended solids discharge into the coast, but it would also be an economic opportunity for Marion Council to actually potentially provide water from the Managed Aquifer Recharge Scheme into infrastructure developments at Flinders University. So it's a really nice loop for teaching, research, and then application within the university precinct. So just looking more at the wetlands, so this is Oaklands Park Road, so we're down in the city of Marion. The Sturt River channel, which we've seen a picture of. The channel has, for goodness sake, the channel has a sump with a pump in there. It monitors in that sump, it monitors conductivity and turbidity. The water then is taken in to a sump, another pump sump. It goes through a gross pollution trap. Oh dear. And then it goes to this is very sensitive. It's my big thumbs. Okay, so it goes into a gross pollution trap, goes then into a deep sedimentation basin to allow suspended solids to settle, and then it moves through in two parallel wetland systems with reed beds, and then ultimately to another collection system, goes to a storage tank, and then it's pumped, and these systems here, these are the well heads. There's 4 of them around the wetland, and that injects it into the T2 aquifer storage in the winter and subsequent reuse in the summer. And then oh dear, I hate this. And then it's distributed for green space within Marion City Council. I should say that the Oaklands Park wetland as well, it was the old driver vehicle licensing centre, and it's now it's the most visited asset in Marion District Council. So the community really enjoy that open space and being able to walk next to water, etc., as well as being a resource for managing stormwater. The water also is used for irrigation of trees in the urban landscape. So what I'm looking at is what we're looking at with education on this site. As I say, it's only 10 minutes away from Flinders University. It's a tremendous asset for education in my view. We're partnering with Marion to make it an education centre. And one of the things that we did, the university did, was that Marion obviously had some monitoring equipment in the Sturt River. We then the university then funded 2 additional monitoring stations through the wetland so we can look at water quality as it moves through the wetland. And then Marion had another monitoring station just before the injection into the aquifer. So we've installed these solar-powered monitors in this site for teaching purposes. We use the Marion servers. The data all goes up to Marion servers, and then we can draw it off at the university for teaching and research purposes. And they monitor things like DO, pH, temperature, conductivity, turbidity through the wetlands. We can get access to these data in terms of real time for teaching in the classroom. This is a fairly boring classroom environment. We do things like looking and interrogating pH, DO, and getting students to think about what's going on in the wetlands, why these values change seasonally, daily, hourly, what are the issues. It's a great training tool, a teaching tool for how these systems operate. We can look at things like turbidity and conductivity all in real time, and the students can interrogate this data. But more importantly, we can get them out there as well, and they can be out there sampling and doing water quality sampling and learning how to do on-site assays and nitrogen, phosphorus determination, etc. And of course, one of the issues that I recognised early on was if it rains, it's a pretty miserable experience down there. If you're out in the rain, you try and teach students, it's not the greatest place to be. So we've partnered with Marion and the university to develop an education centre at Marion Wetlands. And the idea is to have a more interactive classroom facility that's adjacent to the wetlands so the students can see what they're studying and what they're being taught. And also a wet area, I'm loath to call it a lab area, but a wet area where both school children, our university students doing various topics, and also research students could actually have access to a serviced facility with power, water, gas, etc. for research on site. And that's just looking for final approval from Marion to start construction of that. So the potential users of that centre would be schools, and the university is looking to use PhD students, as usual, to support school trips and school visitors. Community, citizen science, etc. A demonstration site. Marion is really part of the MAR users group. It markets itself really well to national and international visitors. And of course, we're interested because we can do course and topic delivery, undergraduate honours, masters and PhD student research. And I'm going to talk a bit about the research on the next phase of the talk. So research, there's two PhD candidates, Peter Reeve and Amir. These are the two guys who are doing this work at the site. You can talk with them later if they would put their hands up to identify themselves. So one is funded with the Local Government Association and the MAR Users Group. The MAR Users Group is a group of about 7 councils within South Australia that have a common interest in MAR in urban environments. Local Government Association supports research and development for, obviously, district councils. And my background is I'm actually an environmental health professional, so I'm interested in where environment impacts on human health and well-being. And of course, if you're using stormwater and storing it in a managed aquifer, then you've got various agents that could be harmful to human health at the reuse stage, where people might be exposed when you're irrigating open spaces and they may be present. So it's interesting to look at both how chemicals of concern and contaminants impact and how they behave when they're stored in the aquifer, and also how microorganisms behave when they're stored in the aquifer, because you're interested in minimising the potential for harm to human health. And one of the areas that we're interested in is the organic chemicals that come in stormwater. They're recognised by local government and other organisations as issues. And the project has attracted significant collaboration. So we're working with Rai Kukana within CSIRO on this project as well. And what we're looking at is we'd like to look at how the aquifer substrates, the solid material that's in the aquifer, how that reacts with and interacts with organic chemicals and how they behave and how they get degraded or removed. And what we're doing, which I think is interesting, is we're using authentic materials. We're using the material that's actually come from the T2 aquifer. And if you remember, that was described as a limestone aquifer, and we're using the water from the wetlands, the authentic water from the wetlands, as the suspension media for these chemicals, and we're looking at how they behave and how they interact with the solid material. So the chemicals, we've picked a range of chemicals that are characteristic of some of the classes of chemicals we've got concern about, which analgesics, herbicides, surfactants, endocrine disruptors, stimulants, hormones, insect repellents, and antibiotics. And we're using this material from the T2. Now, it's interesting that that was described as a limestone aquifer. We've got material that's got 12% calcite and 70% calcite. So it's a very heterogeneous aquifer, and that's part of the reason we're interested in using the authentic material. We can collect the wetland water, we can incubate it with the organic chemicals of concern, look how the concentrations of the chemicals change with time by interaction with the aquifer material, and make some decision about how these chemicals are being attenuated by storage in the aquifer over time. We can also use column studies where we can pack columns and have a more realistic approach where we've got the water and the chemical flowing through and interacting with the substrates in a flowing media. We're also interested in, one of the areas we think that's been underdone is that if you don't stabilise the water being injected into the aquifer and you still inject large amounts of nitrogen, phosphorus and carbon, one of the issues with sustainability of managed aquifer recharge is actually biofilm development within the aquifer, and it actually will clog the aquifer and start to cause problems, operational problems about having to regenerate the borehole. But what really has not been studied to any great extent is how that biofilm interacts with chemicals of concern and how that biofilm interacts with microorganisms. And we're looking at that in our studies. Second one, very quickly, is EMEA. He's interested. MS2 is a virus of bacteria. It has no implications for human health and well-being. It's used as a marker of viruses in wastewater and stormwater. And what we're looking at is how this phage, as a model for potentially human pathogenic viruses that might be in the stormwater and injected into the aquifer. We're using this as a model viral particle, again to see how the virus interacts with the particles, the water and the biofilm. And I'll quickly go through this again. This is Olympic boring as providing material for us at sites from mainly from the North Adelaide Plains. We can dry it, we can sieve it, we can do all these things in the lab, we can get the particle sizes. And what EMEA has been doing in the first part is looking at these different particle sizes and how they interact. And the reason we're interested in particle size is the smaller the particle size, the greater the surface area we have and the greater absorbent capacity we have for these viruses to be attached to the substrate. So we can grow this organism up in the environment, in the lab, mix it with the thank you. Mix it with the material, and we can look and see that, as we might expect, the coarse material does not absorb the virus as well as the small particle material. And with this information, we can build then on a whole series of experiments, including column experiments again, to look at how these things interact with the substrate. And again, I'd like to thank all these organisations that have supported this. And again, it's that word collaboration. You can't do this in isolation. You have to do it in collaboration. Thank you.